Our learning goal for today is I can rename a mixed number to help me subtract. Remember to write your learning goal on your note-taking page. Let's take a look at our problem here. Hunter, Jaden, and Mason go bike riding on weekends. On one weekend, Hunter rode his bike for 3 hours. Jaden rode his bike for 2 1/4 hours, and Mason rode his bike for 1 3/4 hours. How much longer did Jaden ride than Mason did? There's a couple things we need to think about. I need to think which operation will I need to use, and which information do I need. So if I'm thinking about the operation that I need to use, it says, how much longer did Jaden ride his bike than Mason did? So I'm comparing the two, and I need to know how much longer something is. So I would have to subtract. The second thing that I have to think about is which information do I need? Well, the question asks, how much longer did Jaden ride his bike than Mason? Well, the problem gives us some unneeded information. It says that Hunter rode his bike for 3 hours. I don't need that information to solve the problem. It's just there to distract me. So I only need that Jaden rode his bike for 2 1/4 hours and Mason rode his bike for 1 3/4 hours. Let's draw a model to help us solve. So I have Jaden rode for 2 1/4 of an hour. So I have 2 hole here on Jaden's. So I need to shade in 1 hole, and I need to shade in another hole, and I need to shade in 1/4 of a remaining hour there. So I have 2 1/4. This would be 1 hole, and this would be 1 hole, and this would be my 1/4. Mason, however, rode his bike for 1 3/4 hour. So I have 1 hole, so that I'm going to shade in here, and I have 3/4 of another hour. So I'm going to shade in 3/4 here. So this is 1 hole, and this would be 3/4. Well, you can see by looking at my model that Jaden actually rode longer than Mason did. This area right here, these two, are the difference that Jaden rode longer than Mason did. So if each one of these squares is 1/4, then 1/4 plus 1/4 would be 2/4. So Jaden rode 2/4 hour longer than Mason did. So if I wanted to rewrite my equation, it would look something like this. 2 1/4 minus 1 3/4 equals 2/4. Well, we need to figure out how to subtract it without having to always draw a model. So let's take a look at a problem here. 5 1/8 minus 3 3/8. There's a couple of ways to solve this. The first one I want to show you is to rename both the mixed numbers as fractions. So we have 5 1/8, and we need to change it to an improper fraction. Let's think about how we did this in class the other day. We know that 8 is the whole, and we have 5 wholes. So we would have 8 eighths plus 8 eighths plus 8 eighths plus 8 eighths plus 8 eighths. But I can't forget my last one here that I have 1/8, and it'll be plus 1/8. So if I added all these together, I would have 8 5 times, which we could multiply. 8 times 5 is 40, and then 40 plus 1 would be 41, and my denominator stays the same. So 5 1/8 is the same as 41 eighths. We know our little trick that we learned before, that was just to multiply and then add. So we would do 8 times 5 is 40, 40 plus 1 is 41. But this is the why. This is why we do that. So let's take a look at 3 3/8. So let's do our little trick that we know. So 8 times 3 is 24. 24 plus 3 is 27. So now we have 41 eighths, and we have 27 eighths. Well, we need to subtract these two numbers. So let's take a look at 41 eighths minus 27 eighths. I need to subtract my numerator. So let's try 41. I'm going to have to rewrite it. minus 27, because I don't want to try to do it in my head and risk making a mistake. So I regroup my 4. 4 becomes 3. 1 becomes 11. So 11 minus 7 is 4. And 3 minus 2 is 1. So my answer here for 41 minus 27 would be 11. And my denominator doesn't change. So it's going to be 11/8. So I have 5 and 1/8 minus 3 and 3/8 equals 11/8. Or I could change it back to a mixed number, and my answer would be 1 and 3/8. So 5 and 1/8 minus 3 and 3/8 would equal 11/8 or 1 and 3/8. I can rename both mixed numbers as fractions the same way I just did the other one, except this problem looks a little bit differently. It looks a little bit different. This problem is actually vertical. It's the same way we solve it, except it just looks different. So let's do the same way. We're going to change both of them to improper fractions. So 6 times 3 is 18. 18 plus 3 is 21. And then we're going to just bring our 6 over. We do this because it's 6, 6, 6, 6, 6, 6, 3 times, and then we have plus 3, 6 would be 21, 6. Then I can change the other one too. The same way, 6 times 1 is 6, plus 4 is 10. So I would have 10, 6. And so I'm going to still subtract these just like I would any other way. Let me write it like this just so you can see it again. So I'm going to write it horizontally here. 21, 6 minus 10, 6. So we can keep that in our mind because that's how we've seen it so far. So 21 minus 10 would be 11. I can do that one in my head. And then 6, I don't do anything to the denominator. Just like I wouldn't do anything here to the denominator, I don't do anything here. So my denominator stays the same. So my answer should be 11/6. I can also change that again. So I can think of it like this. 6, 6 is a whole, and I would have 5, 6 left. This would be my 1 whole, so my answer would be 1 and 5/6. So 3 and 3/6 minus 1 and 4/6 equals 11/6. Let me circle that one. 11/6, or I could say it equals 1 and 5/6. There's another way to solve this problem. This one seems a little trickier, but I think that this one will be really useful for us. Let's rename the first mixed number. So I have 5 and 1/8. Here's my problem if I'm trying to subtract this one. 5 and 1/8 minus 3 and 3/8. I cannot subtract 3 from 1. So that's why I'm having a problem, and I have to regroup and I have to rename the first mixed number. So let's take a look at this first one here. I'm going to change 5 to 4 plus 1. And I know that 4 plus 1 equals 5, of course. And then I'm going to leave my 1/8 because I can't forget this one here. So I have this 5 is now 4 plus 1, and 1/8 is going to stay the same. Let me erase that so it doesn't get confusing. Okay. So now I have 4 plus 1. Well, I'm going to rename that 1 just like we have in class. I'm not going to call it a 1 anymore. I'm going to call it a whole, which would be 8/8. So I can add all these together. So now my new problem is going to be 4 and 9/8 because I added 8 plus 1 is 9 and my denominator stayed the same. So 4 and 9/8. And then I'm going to subtract 3 and 3/8. Well, now I have no trouble subtracting because I can actually subtract 9 from 9 minus 3. 9 minus 3 would be 6. My denominator, well, it stays the same because my whole is still 8. And then I just have to remember to subtract my whole numbers. So 4 minus 3 would be 1. So now my answer is 1 and 6/8. It looks a little tricky right now, but I'm actually saving myself some work because I don't have to change both of the numbers. I only have to change one. Let's try it again. This time I have a vertical problem. I'm going to rename the first mixed number. So 4 is actually going to be 3 plus 1. So let's rename this one. But remember, my 1 is actually going to be my whole 10 tenths. So 10 tenths plus 7 tenths plus my 3 whole. So this one would be renamed to be 3 and 17 tenths. And 1 and 9 tenths, well, it would stay the same. That's why it's saving me time. Now I can subtract. So 17 minus 9 would be 6. My denominator stays the same, so that would stay 10. And now I can just subtract 3 minus 1 is 2. So 4 and 7 tenths minus 1 and 9 tenths would equal 2 and 6 tenths. And now I don't have to go back to a mixed number if I ended up with an improper fraction like I did on some of my other questions. So this step actually saves us a little bit of time. I want you to try a few practice problems on your own. I want you to rename both fractions as improper fractions on this one. So I want you to try this one the first way we did it. So you would have to actually rename both of the fractions to improper fractions. I want you to have practice on both ways. So I also want you to do number 2 a different way. I want you to rename the first fraction as an improper fraction by our regrouping method. So if you need to look back at the video, please make sure you look back at our other practice problems, the models that I've shown you, so that you can answer these the correct way. If you have any questions, make sure to write it down. I will see